Okay, hi everybody. This video is to introduce you to RStudio and RMarkdown. So R is one of the other main types of software that we're going to be using in landscape ecology this semester. And it's a very powerful analytical software. It allows you to analyze geospatial data or biodiversity data, and it's a very useful skill to have experience with. It's a very marketable thing to be able to say on your resume that you've got experience with R. And so that's one reason why I include it in this course. Remember that the main premise behind landscape ecology is that the world is heterogeneous. And so you're going to have a way of quantitatively distinguishing pattern from just statistical noise. And so R allows you to do these kinds of analyses. So once again, we're working from my home, live from my desktop. So let me share my screen here. Okay. And so again, you go to the Landscape Ecology Google Drive folder, the lab materials, and you download all of the data files and such here to your desktop Landscape Ecology folder. You know, you see some of them are CSV files and some of them are zipped folders, and that's the data we're going to be working with. Okay. Then the computers in the classroom and in the library, they've already got R installed. But if you want to install it on your home computer, then you just go to a search engine and you just say download RStudio, and you go to this website, Posit website here. The first thing you have to do is install R. That's sort of like the base brain. And then RStudio is the nice graphical user interface for it. So first download and install R. Just click on this, follow the instructions. Once that's done, then click on this and download RStudio. Again, click on this and follow the instructions. Okay, that's if you want to have it at home. So I've already done that, so let's go ahead and get started. So I'm going to open up RStudio here. And what will come up with are these three windows. So this is the console window, and this is where the code executes. Over here, the environment, this is where the data sets that you read in, this is where they will be stored. And then down here is where you'll have any plots, and you can find out information about packages and so forth, okay? If you want to follow along with this, you go to the Landscape Ecology Lab Materials, and this lesson is the one on Intro to R, RStudio, and RMarkdown. And so you just open it. It's a Word document here. And I'm not going to be going through all of this. You should. But for the purpose of this video, this is just going to be, quick and dirty kind of thing to get you, ease you into it, get you familiar with it. So let me go over here. This console window, you can work from it, but you shouldn't. Instead, you're going to want a fourth window that is a script file. That script is where you write your code, and that's what you would need to build for your homework. So to make that, you go to File, New File, RScript. And this window opens over here. We'll make it a little bigger, like that. Okay, so now we're ready to go. The very first thing you have to do in R is you have to tell it where the data files are that you will be analyzing. For you all, it's in your desktop landscape ecology folder. You have to tell R where that is. That's called setting your working directory. And you have to do it every time you open R. Every time. So you go to Session, Set Working Directory, choose. And on yours, it'll be on the desktop and so forth. For me, I'm going to have to noodle around, find out where the heck it, okay, here we go. This is what I want. Okay. So notice this blue line of code down here that appeared in the console window. That was that code that was being executed. So set WD, set the working directory, and here's the path name on my home desktop. Okay. On yours, it'll be desktop landscape ecology. Okay, so now R knows where to go to find data files. In order to do things in R, there are different functions that have been written that are in different packages. So there's a package for the analysis of geospatial data. And there's a package that's really good for analysis of biodiversity data and so forth. And so you have to install those packages. So in my code window, my script window, I'm going to type in install packages. And one of the very commonly used packages in ecology is called vegan. That stands for vegetation analyses. Every line of code in your script has to be run or executed. You can do that by clicking anywhere on the line and clicking run. And down here in the console window, you'll see that it has installed the package named vegan. Cool. You can also run a line, clicking anywhere on it, and then just clicking Control, hold Control down, and Enter. It's doing the same thing down here. Okay, so you have to execute every line of code. Okay, now that I've installed this package, I never have to do that again. But every single session of R, I have to tell it, okay, I'm going to need this package, that package, and the other package. I've got this vast library of packages, but I'm only going to need this one, and this one. So you have to tell R, hey, go to my library and get this one, and this one. For each lesson that we do in R, I'll tell you which packages you need to have in library. You have to install them first, and then library them. Okay? So there are some that I've already installed. I now library them. Library means, hey, R, go to my library and get that, please. So I tell it, library, vegan. Again, run the line, Control, Enter. Down here in the console, it says a warning message, package vegan was built under a previous version of R. No big deal. It just means that my version of R is more advanced than the one that the package was built under. Who cares? This other package, permute, is an ancillary package that vegan requires. It already downloaded it for me automatically when I installed vegan. So, okay, cool. We're ready to go now. I have already done install packages on some other things I'm going to use for this demo, so I just need to library them now. And so I say library. One of them is called raster. Run the line, Control, Enter. And down here, it's doing its thing. It's loading its little buddy, package called SP. And once again, it's saying, hey, it was built under a slightly older version of R. Who cares? It'll work. And then I also need to library the package Terra. Control, Enter. Same thing down here. Okay, we're done. So you install packages once. You have to library what you need every time. Okay, now we're ready to read in some data. You can read in CSV files or Excel worksheets or raster data sets or whatever. So what you do is you tell R, hey, I'm going to read in a data set and I'm going to give it a name. I'm going to call it, it's an R object, and the data that I'm going to work with first, I know happens to be about beetles. And so I'm going to create an object with a name that I give it called beetles. And then I do this little arrow and I say, hey, this thing I'm creating, I'm naming it beetles. And then I read.csv, ground beetles abundance. CSV, is it ground beetle abundance or ground beetles abundance? Let me check on that because typos are a thing. It's beetles. Okay, good. Okay, so now run the line. And hey, this thing appears over here in the environment, beetles. If I click on it, it opens over here and you can see each one of these columns. These are abbreviations of the scientific names of different beetle species. And then each row, there are 18 different sites. And then we have abundances here. Okay, so it's a site by species data set, very common in biology. Okay, well, that's cool. But I may want to know, like for example, this first site here, there's a bunch of this species, but none of this, and none of this, and none of this, and none of this. And so how many species of beetles are at this site? And which site has the most? That kind of thing. So that's what these packages do. They have quick little functions that allow you to calculate that. So let me close this. And the function that allows me to answer those questions is from vegan. It's called spec number. And I say, hey, please perform spec number on the object that I created called beetles. Run the line, Control Enter. And down here you see, so Site 1 has 18 species, Site 2 has 15, and so on. Okay, fast, easy, super, super neat. So it's not important. This isn't a course on R. It's not important that you don't understand everything about the code. You know, like why did we use quote marks in this line in line 5, but we didn't in line 6 kind of thing, right? That's not important. In the lessons, you'll work through the code. It doesn't matter that you don't understand what each little word and syntax and so forth means. It's like when you're cooking a recipe. When you're following a recipe, it doesn't really matter if you understand, you know, why does this recipe call for a 1/4 teaspoon of baking powder, but this other one call for a 1/4 teaspoon of baking soda? Until you get more deeply into the chemistry of cooking and understand what baking powder and baking soda do, then you'll be able to say, oh, that's why this one calls for soda, this one calls for powder. I don't have any baking soda. What can I substitute? That requires a deeper knowledge. When you're just starting out cooking, just follow the recipe and the cake will turn out. So that's what you're doing here. At the end of the semester, you're going to wind up with a series of scripts that allow you to do certain functions. And so like this one will allow you to analyze raster data, and this one will allow you to analyze biodiversity data. The same way that a recipe will be like, this one's to make a chocolate cake, this one's to make apple pie, and so forth. Okay? In the exercises, you'll work through the lesson, the demo, and then for the homework, you'll have to modify that script slightly and then evaluate the output. So don't get hung up about not understanding what every word and symbol and so forth means. Just follow the recipe. Okay? So for these beetle data, I also know that there are some environmental data that were collected at those sites too. And so I want to read them in too. And so I'm going to give that new data set a name. I'm going to call it Environ. Notice how this pops up. Environment. These are functions. You don't want to give an R object the same name as a function. So I'm not going to use the word environment. I'm just going to say environ. That's good enough, okay? And the arrow, there you go, Nancy. The arrow says this thing I'm creating is called environ, okay? It's the name I'm giving it. The names of the R objects you create need to be short, no spaces, no symbols, okay? Short, easy. So now I'm going to read in these data. They're also a CSV file, and it's called gbsite.csv. You have to include the file extensions. Again, run the line, Control Enter. And over here, Environ pops up, and we click on it. And you can see here's each one of the 18 sites. Max height is the maximum vegetation height at each site, and then there are 3 habitat types: edge, grassland, and woodland. And you can see that there are 6 replicate sites for each one of the 3 habitat types. Okay, so then which habitat type has the most beetle species? So I can use vegan to quickly answer that. So I'm going to make a plot. I'm going to make a box plot. Box plot. Again, don't get hung up about the syntax. Just follow the recipe. X label equals habitat type. Y label equals number of species, and execute. And there we go. Here's a box plot with the average, the 95% confidence intervals across the replicate sites for each one of these 3 habitat types. And you can see that grassland sites had the most beetle species and woodland ones had the fewest. So that's cool. Okay, but this is landscape ecology. Let's look at some spatial data. I have a raster data set of land cover data, and it's from Wright County, Minnesota. And so again, I'm going to create an R object of my choosing. The name's going to be of my choosing. I could call it Wright, whatever. I'm going to call it MN because that's the abbreviation for Minnesota. Little arrow that says I'm creating this. Now this is a raster data set, so I can't use read CSV. I have to use functions from Terra and later on from raster and so forth in order to be able to read it in. And so I say rest, and it was called write 2016 NLCD. NLCD means National Land Cover Dataset. .tif, and once again, execute the line, control enter or run. And over here, formal class spat raster, spatial raster. If you click on this, however, it's not like a spreadsheet like Beetles and Environ were, right? Because this is a raster, this is a map. So it doesn't make sense to look at it this way. There's a different way you can look at it, however. You can call it. I've created this thing called MN. I've created Beetles. I've created Environ. I can call them. I can say, hey, Beetles, what you look like? And I can run that line. And it's the same data. You see these the abbreviations, the sites, the abundances, the same thing that we get when we look at it up here. Okay. Same thing for Environ. If I call Environ, same thing that happens that we saw up here. But when I do that for MN, I get something that's more informative. I can see that it's a spatial raster, that it's got 1,697 rows, 1,979 columns. The resolution of the data are 30 by 30 meters. The projection is the Albers conical equal area, and so on and so forth. So you can call your objects to learn a little bit more about them. Okay, well, this is a raster. It's a map. Let's plot it. Plot the thing I called MN. And here it is over here. Each one of these numbers indicates a different land cover type from the National Land Cover Database from 2016 for Wright County. Okay, so this is just a quick introduction to the kinds of things that RStudio can do, how you use it, and so forth. There are three ways that students run into problems. Problem number one, you got to set your working directory every single time. And all of the files that you work with have to be in that one folder. They can't be within subfolders. No. For example, I have a file in a different folder on my computer called birds.csv. It's not in the folder in my working directory. What happens if I try to tell R, hey, go get birds, please? So I'm going to say birds. It's the object I'm calling. Read.csv. It's called birds.csv. Execute the line. It says, no such file or directory. That's the error message that you get when the file that you want to analyze is not in your working directory. So just copy and paste it over in there. Okay, so that's problem number one. Set your working directory every single time. Problem number two, you didn't library your packages. You've got to do that every single time, only the ones you're going to need for that lesson. And again, I will tell you, library these for this lesson. And then finally, it's typos. So for example, let's say I want to plot Minnesota and I misspell the function PLOMN. I run that. It's like, oh, error, could not find function PLO. Oh, you dummy, it's spelled plot. So I go back and I say plot. Things are also case sensitive. So let's say I say, hey, plot MN, but not capital. What does that look like? I execute. It says object MN not found. That's because the object I created was capital M, capital N. So things are case sensitive. That includes the functions as well. So you're going to be able to copy paste a lot of the code over from the notes. But when you type stuff, just be careful. Don't have any typos, that kind of thing. Okay, so set your working directory, library your packages. Be careful with your spelling, that kind of thing. Okay, now for your homework, you're not going to turn in this script file. Notice how it says Untitled 1, it's red, and there's an asterisk. If I go to save it, I just say Control S for save. It'll save it as a .r file, and this is my working directory. It would save it automatically to my working directory. That's not what you turn in. That's the script. That's the code that you can run. You can save that, and you should. I'm not going to do it because this is a demo, and I don't need to do it, so I'm going to cancel that. For your homework, you have to create an RMarkdown file. RMarkdown provides a very nice kind of document. To do that, File, New File, RMarkdown. This window pops up. So you give this thing a title. So let's say it's going to be called Homework 1. This is my name. Here's today's date. And there are 3 format types for your output. You're going to want Word, please. You're going to turn in this Word document that will be created. Okay? And say, okay. Now this window pops up. It's Untitled 2, and I don't know how well you can see it, but it's got a little red thing that says RMD in it. Let me pull this down like this. You can see at the top, this is the stuff that we've just entered here. Homework 1, my name, the date. It's got a Word document, it's the output. Then you've got gray and white, gray and white, gray and white. The gray part is code. The white part, you can write notes. So what I do is the very first thing is I get rid of the white stuff and just delete. I can put stuff here. I can be like, this is my code. I don't have to put a pound sign in front of it. Oh, did I tell y'all about pound signs? I didn't. Let me go back. That's super important. Future you will appreciate this. If you use a pound sign or a number sign, you can write a note. This is a note. If I run that line, it doesn't do anything because that pound sign sets it off as a note. That is super useful for you in explaining what something does. So for example, I can go back up here and I can say, the following line calculates species richness for each site. And that then says, oh, spec number, that's what that does. Okay, cool. So it is good practice to put lots and lots of notes in your R script using the little number sign. Okay, cool. Let me go back to my R Markdown. So I don't have to do that for R Markdown if I write stuff in the white. I just write stuff. So I can get rid of this. I can get rid of this. I can do like, answers to the questions. So you'll have different questions for your homework. So like question 1, maybe the answer is blue. Number 2, it's 13, whatever, right? Again, in the white, you can write whatever you want. In the gray, this is the code. This first chunk of code, leave it. The second one where it talks about cars, cars is a data set that's built into R. That's not what we're working with. So get rid of cars, keep the rest, and get rid of summary cars, keep the rest. Okay? And then go back to your script. And you're going to want to copy the parts that you're going to need for your homework. You don't need to include the bit that was the lesson that you worked through. You just need to do the part for the assignment. Well, let's pretend that this was the assignment. So I'm going to select all of it. I copy it. And then I paste it. It's code. I paste it right there in that gray, in between that little quote, 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 curly bracket, R, curly bracket, in that space, I paste it. That's my code. Very important. R Markdown will have a conniption fit if you include an install packages line. It just is a picadillo of R Markdown. So either get rid of it or put a pound sign in front of it to make it a note. But do not include install packages. You also have to tell R Markdown your working directory. So I go back to my script. Remember, that was the very first thing. It's not even in my script because I did it from this drop-down menu, but it's the very first thing in my console. This blue line, set WD. So I just select it, I copy it, I bring it over here, and I paste it. So you got to set your working directory here too. Okay? And then get rid of stuff you don't need. Like, for example, I don't need to, I've called the R objects again. I don't need to do that. These were errors. I don't need to do that. I don't need to have this line that says this is a note. Okay. So now I'm happy. This is tidy. I've got my stuff. Okay. So now, I can get rid of this. R pressure echoes false. I can get rid of this. In fact, I can get rid of, I don't have any more code. I can get rid of that. Okay. So I've got my top code. Any notes? You don't have to have something here. But then here in the gray is my code. The output you get is going to be everything that we did in the code. So remember, we made this map. We made a box plot. And so that is going to be part of the homework. In order to get R to do that, we say knit. It'll ask you, hey, what do you want to call this R Markdown file, RMD? I'm going to call it demo. Okay, you may call it homework 1, whatever, right? And I say save. Okay, and down here in the console, it's working. The little stop sign means it's doing something. And then over here, you can't see it. Let me drag it over from my other window. This automatically popped up. Here it is, demo.docx. That's the homework file we asked it to create. So remember, this is the note that I had. This is my code. Here's the actual code. Okay. And notice how, like, spec number, here's the answer of the thing that it did, right? And then here's my box plot. Here's my plot here. Answer to the questions. Beautiful. Wonderful. This is what you then email to me as your homework. This allows me to see also if you've got a problem, where in the code it might be and that kind of thing. So this is the document. So that's how you create it. Let's get rid of that. So this thing over here, you create your R Markdown file, leave the first bit of gray alone, write anything in the white that you want. For example, you could write something like, Wright County appears to be dominated by land cover type 171, whatever, right? In your code, no install packages command, set your working directory, and then knit. And it'll create that Word document, and that's what you turn in. Okay, so let me stop sharing. And so that's a quick demo to get you started with RStudio. It's very powerful software, and so this is hopefully to get you more comfortable with being able to use it, because we'll be using it for several lessons this semester. Some people do all of their geospatial analyses in R now. R is free, so it's used by government agencies, nonprofit organizations, overseas, international organizations, and so forth. But I find that there are certain things that ArcGIS Pro does better, easier, faster. You get what you pay for. It's expensive. R being free, there are things that are clunky. And so, for example, changing colors on a map, we read in a TIFF file in the first lesson on ArcGIS Pro, and you can change the colors. Remember the cookie that we made of Llano Estacado? We changed the colors. It was fast, easy. It took a minute, right? Doing it in R, it's a lot of lines of code, and it's really complicated. So some people, they do everything in R, especially if they don't have a budget to pay out a license for ArcGIS Pro. But being able to say at the end of this class, you have experience with ArcGIS Pro and with RStudio RMarkdown, those are skills that employers are going to want to hire. So hopefully today you feel a lot more comfortable with using R.